is evaporated between the application by the directing a stream of warm dew from a hair dryer for a perfect result. If the compounds are the thermally stable called or should be used, and commonly application are also available to apply a very narrow uniform streak of spot along the length of the chromatoplates. The chromatoplate is now ready to develop. So this one was the fourth step, how to apply our sample to the TLC plate. In this we have studied that the baseline should be above 2.5 centimeter from the edge. Then we have to place a 1 ml of our drop, not more than a 1 ml, and we have to thermally stable our solvent application, and then we have to take it for the development. Now this is the fifth step in which the chromatogram is developed. This is the development of a chromatogram. The development of a chromatogram are carried out by different techniques. The first one is the ascending development. In the ascending development, we have to place our chromatoplate in a chromatogramic tank, and the chromatogramic plate is placed between the glass plate, and through it is filled with the solvent. The tank is closely firmly with the lid, and solvent is allowed to move upward. As the name indicates, this is ascending development, moving from down to up. After a certain time, when the solvent has moved about 10 to 12 centimeter above the origin, the plate is removed from the tank. This is the timing when we have to remove our TLC plate from the tank. The next type of development is the horizontal development. In these methods of the development, the solute sample is placed at the center of the chromatoplate and developed by bringing the solvent to the plate through filter strip of the same width as that of the plate. This is known as horizontal. Means the plate is placed and over that a filter paper is placed and horizontal development occurs. The third one is the multiple development. In this method, the development of a chromatogram is carried out repeatedly and consequently with the same solvent in the same direction each time after drying. Multiple development means to develop the same chromatogram with multiple times in the same direction after drying of the first one. Means the first one chromatogram is developed, dried, then developed, and then dried, then developed, and then dried in the same direction. This process is known as the multiple development chromatogram. The fourth one is the stepwise development. In this type of development carried out consequently with the different solvent in the same direction, and one of the solvent is allowed to run longer than the other. In this stepwise development, we have to just change our solvents. We have to change the solvents. Once the solvent is used, then we have to change the solvent and the next solvent is used, and the time given to that solvent is allowed more than the other one. The fifth one is the two-dimensional development. In this development, the sample is spotted on a carrier of the chromatoplate and then developed consequently in two directions, either in the same solvent or in the different solvent. It doesn't matter, the solvent may be same or different, but the dimension should be or the direction should be same of in consequently one and another. Then after development, as our TLC plate is developed, then we have the visualization of TLC plate. So in the sample is visualized on a plate by two methods, physical and chemical. Physical method is also known as destructive, while the chemical is known as destructive. Okay, in this physical method, UV chamber is used, and it is about 254 to 365 millimeter in wavelength, because some aromatic group shows fluorescence like silica gel, and silica gel is whenever used in a TLC, so it have a fluorescence, a light, a shining. In a chemical method, we have to use a dilute chemicals for the destructive compounds. This was the visualization of TLC plate. Then we have the evaluation of TLC plate, the checkup of the TLC plate. So we have quantitative evaluation, direct methods, comparisons of the RF values between the different RF values. We have to compare the RF values in different solvents. The identification take place, the spot area of the highest relationship, measurement of the area of the spots. These all are the steps through which we can evaluate our TLC plate. In this picture, you can see the steps of the thin layer chromatography, or the procedure of the thin layer chromatography. As you can see in this first, we have just our chromatographic tank, our solvent solution, and our TLC plate. This is our baseline. After 5 minutes it start traveling, and after 10 minutes it got completed. In this we can say that this one is our A, this one is our B. A is referred as the travel component, and B is referred as the solvent of our sample. So this is the formula of retardation factor, or RF value, means the distance traveled by the solvent, or the distance traveled by the components, or the distance traveled by the solvent. And we can say that the distance traveled by the solution, or the distance traveled by the solvent. This is the formula of retardation factor, RF value. What is the retardation factor, or the TLC RF value means? It is the ratio of the distance traveled by a substance to distance traveled by the solvent front. Higher the RF value, lesser the polarity of the substances, and lower the RF value, higher is the polarity of the substances. It shows about the polarity and the affinity of the sample and the solute of the stationary and mobile phase. Okay, then this is the retention factor, or RF values. So the behavior of the compound on a TLC is usually described in terms of relative mobility of or RF values. Then the RF, or the retention factor, is a unique value for each compound under the same condition. Is by checking the RF value we can say that this one is that one compound, or the RF values shows us, identify us the different compounds, different solvent, different samples. Then we have relative RF. Relative RF means that the values are reported relative to the standard. Means we have to check the difference between the standard and the sample. The formula for the RF value is the distance traveled by the solute, or the distance traveled by the solvent. Then this is how to calculate the retention factor, the RF values in the thin layer chromatography. So in this we have the baseline, the potential point of interest, and the potential point of interest. The baseline is the very starting point where the solvent start carrying the solute, and this is where the sample is spotted. This is the baseline. Then we have the solvent front, the point of interest, a spot that moves up with the TLC plate, that is known as point of interest. Then we have the solvent point, the solvent front. The solvent front is the very topmost front, or the topmost line till which the solvents kept moving, and the retention factor is the abbreviated as RF, the ratio of the distance of the spot travel to the distance of the solvent travel. This is a picture or a view of a TLC plate. Now we have the application of thin layer chromatography, that where how we have to use this thin layer chromatography. So this is used in the monitoring and the progress of reactions. Then it is used to identify the compounds present in a given mixture. It means identification of different compounds, determine the purity of substances, analyze the ceramides and the fatty acids, detection of the pesticides or insecticides in the food and water, analyze the decomposition of fiber in the forensics, assign a radiochemical purity of a radiopharmaceuticals, identification of medical plants and their constituents. These all are the sites where the TLC is used. Now we have the advantages of thin layer chromatography, that why we prefer thin layer chromatography. So due to this, some of the advantages of TLC: it is simple process and short development time. It it occur in a very short time and very simple process. It helps with the visualization of separated compounds spot easily. It can be seen easily with having not any use of chemical or any other compound. It helps in isolating of most of the compounds. Mainly, most of the compounds can be isolated through TLC very easily. The separation process is faster and selectivity of the compound is higher, and even the small differences the chemistry even for clear separation. It gives us a very clear separation, a very uniform separation. The purity standard of a given sample can be assessed easily. It is a cheaper chromatography technique. That is why we used TLC very uh, adversely. It have many advantages but also have some limitation, some limits where the thin layer chromatography failed. And the first one is it cannot tell us the difference between the enantiomer and sub-isomers. So this one is the limitation. Another one is, in order to identify the specific compounds, that the RF value for the compounds of interest must be known beforehand. The TLC plate do not have long stationary phases, therefore the length of separation is limited and compared to other chromatography techniques. So these are some of the limitations where the TLC get failed. Now we have the disadvantages of thin layer chromatography. So the thin layer chromatography plate do not have longer stationary phase, as the stationary phase of the TLC got damaged within a short interval of time. The second one is, when compared to the other chromatographic techniques, the length of separation is limited. It is have a limited length of our TLC plate. As much the TLC plate is, that is the length or the limited length for the chromatography. The results generated from the TLC are different to reproduce, since the TLC operates as an open system. Some factors such as humidity, temperature can be affect the final outcome of the chromatogram. As this chromatography is a physical method, so it can be affected by different factors as humidity and temperature, etc., or it can be affected by a human or any problem due to the man or human. The last one is the detection limit is high, and therefore if you want a lower detection limit, you cannot use TLC. It is only a qualitative analysis technique, not a quantitative analysis technique. It can have a result of quantitative but not more accurate, not more specific. If you have any sort of queries, so you can ask, please. This was all about my presentation. Thank you. Allah Hafiz.